Question 6, the cyclopropanation question. Now, I did not ask you for mechanisms here. I'm very careful. When I want a mechanism, I will ask for it. I gave you some context on what this does and why it's important. But basically, I also told you it's a cyclopropanation. How do I want to do it? There are two ways to put in a cyclopropane that has only hydrogens attached to it, which is the case here. Either I use diazomethane, or I use the Simmons-Smith reagent, which is diiodomethane and a zinc and copper combination. One of those two will get me this reaction done. That's letter A. That's all I needed for letter A. It's just what reagents will do it. What methods do I need to use to do it? Letter B, what's the intermediate involved, which is more important for diazomethane. It's a little less clear with the Simmons-Smith reaction, but basically we're creating a carbene at that point. The intermediate is this. I have a neutral carbon with an empty orbital. So this is a little weird. It's a violation of the octet rule for carbon. It's extraordinarily reactive because of that. But it has a lone pair in one orbital and an empty orbital on the same carbon, which means basically, in a very oversimplified sense, it can act as a nucleophile and an electrophile at the same time, from the same atom, which is pretty much what cyclopropanation is. Even more so if we try to rationalize what happens with the Simmons-Smith reagent, we really are looking at a nucleophile-electrophile behavior on the same carbon at the same time. So that's all I needed for this question. Two methods and an intermediate. In one case, it's generated by nitrogen being lost. That's diazomethane. In the other case, it's generated by a metal insertion between one of the carbon to iodine bonds. So I have one iodide as a leaving group, somewhat cationic carbon at that point. The other iodine ends up with a metal there, so I get a somewhat anionic carbon at that point. So overall, I have the same carbene type problem, but I still have groups that are technically attached.